by 2020, it's expected to have about 7 million small unmanned aircraft systems or drones in the sky. And out of those 7 million, there will be 2.6 million commercial operations. So you quickly realize that the current way of managing traffic may not scale.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 151. What's going on with efforts to develop the unmanned traffic management system? If we ask today's guest, he would tell us a lot has been accomplished and there are some exciting things ahead. Parimal Kopardekar, or PK for short, serves as manager of NASA's Safe Autonomous Systems Operation Project. The goal of the project is to develop autonomy-related concepts, technologies, and architectures that will increase efficiency, safety, and capacity of airspace operations. At NASA, PK has initiated many innovative research projects. Prior to this current project, he managed the Next Generation Air Transportation Systems Concept and Technology Development Project. He has published more than 40 articles and is the recipient of numerous NASA awards, including the Outstanding Leadership Medal and Engineer of the Year. He holds a doctorate and master's degree in industrial engineering and bachelor's degree in production engineering. In this edition of the Drone Radio Show, PK talks about NASA's role in developing the Unmanned Transportation Management System and shares what's been accomplished, the current status, and what we can expect in the future for unmanned traffic management. But before we hear from PK, I want to thank those of you who have been supporting my funding campaign on Patreon. For as little as $1 per month, you can help defray the costs of production and keep the podcast going and growing. Go to patreon.com/drone radio show to join the team. Now let's learn how NASA is working to integrate unmanned vehicles into the national airspace with Parimal Kopardekar. Let's pick up the interview where I asked PK to introduce himself.
My name is Parimal Kopardekar. Usually everybody calls me PK. That's my user-friendly name. And I am senior technologist at NASA, focused on air transportation system. I also am principal investigator for Unmanned Aircraft System Traffic Management, or UTM, which is a research activity that's focused on safely enabling large-scale, small unmanned aircraft system operations in the low-altitude airspace.
PK, is it safe to say that NASA is the overall coordinating body for all of the UTM efforts that we hear about?
Yeah, NASA is definitely working to be the facilitator of making sure all the efforts related to UTM are coordinated. We have very tight coordination and relationship and collaboration with FAA and industry partners. So it's really, if you look at it, there are three entities, NASA, FAA, and industry, and NASA is sort of facilitating the effort.
What was the impetus behind the UTM?
That's a great question. I've been working on air traffic management related research for almost 25 years now. And about 4 years ago, I started to think about what other users will enter the airspace and what would be their needs. And one of the things came to my mind at the time was unmanned aircraft system operations, particularly the smaller unmanned aircraft systems who will operate in the lower airspace. And at the time, I felt that there was basically an emerging need to enable their operations, particularly beyond visual line of sight, multiple operations simultaneously happening in the same airspace in the vicinity of helicopters and the manned aircraft. And we needed some way to organize that so that the overall safety of airspace operations is maintained. And that's how the kernel of UTM started. And we started to talk to industry members to see who is all interested in working with us, and slowly the partnerships and collaborations grew, and FAA relationship got solidified, and now it's really a joint activity between FAA and NASA.
Can you give us an idea of the nature and the magnitude of the challenge? What are we up against?
That's a great question. So if we look at the current manned aviation, we have about 50 to 70,000 operations every day. One operation is arrival or departure. And at a time, about 6,000 at peak traffic happens. This is the manned aircraft that you see in the sky. If you look at the unmanned aircraft systems, particularly the smaller ones, which are the 55 pound and below, if you look at their forecast, by 2020, it's expected to have about 7 million small unmanned aircraft systems or drones in the sky operating, not necessarily all at the same time. And out of those 7 million, there will be 2.6 million commercial operations. So if you compare with the manned aviation and the unmanned aircraft that are emerging, you quickly realize that the current way of managing traffic may not scale with that many vehicles operating. So we decided to look at what else can we do, how best can we actually enable these in a safe manner. And we realized that the current bottlenecks of the manned aviation are gates, runways, and air traffic control system, and the workload that's required for air traffic controllers to safely manage the aircraft. Then we turned that problem into upside down and said, let's figure out, understand the expectations and the constraints and directives from the air traffic management system. So, for example, there is a security event or presidential flight, or there is firefighting, or there is airport action, so don't go there. Then we said, okay, let's understand the constraints, and instead of having air traffic controller give directions to every pilot and every operator and every step of the way, we let the operators of the drones figure out how to best maximize their efficiency in their routes and their areas of operations. So you let them understand the constraints, you let them understand what else is happening in the airspace, and then they can decide what best route or area of operation or the time that they can actually adopt to meet their business goals. So that's a model that's sort of different than what happens in the current air traffic management, where pilot has to get clearance from controller every step of the way. The reason being that air traffic controller is the only one that has complete picture of what is happening in the airspace. Here, by digitally connecting everything, we are allowing to have operators the situation awareness of all the constraints as well as the other airspace user operations. That allows them to basically plan, schedule, manage their own operations.
Obviously, it requires that all drone operators are playing by the same rules and that they're responding in a way that everyone would expect them to. Now, dealing with people who ignore the rules, that's one of the big challenges, isn't it?
Exactly. So in terms of UTM, US Traffic Management, we have several services we lay out so that everybody plays by the same rules. These services are authentication and authorization. And by the way, FAA has already implemented that service through low altitude authorization and notification capability, something is called LANs. So that authorization and authentication is one service. Second is planning, track and locate your vehicles, communications, and avoiding other vehicles. So we laid out a bunch of services based on the principles that we want to see in the sky, which is everybody stay away from each other, right? So the fundamental principles are manned aviation has a priority, unmanned aircraft will stay away from the manned aviation, unmanned aircraft and other unmanned aircraft will avoid each other. Operator and operator-supported systems have complete awareness of constraints and other operations in the sky so they can avoid each other. And then the public safety will have priority access. So using those principles, you can categorize these services that I mentioned. Now, these services then can be basically provided by third parties, what we call US service suppliers, or the operators themselves. So in some cases, the operators and service suppliers would be the same, like in case of large fleet users of drones. In other cases, they may be different. But the fundamental part of that, being able to share and care about each other, is ability to talk to each other in the common language. So we prescribed the data exchange protocols. Our team defined the application protocol interfaces. So everybody, when they connect with each other, they are able to talk to each other and share information about their intent and areas of operations seamlessly.
Can you outline what's been accomplished so far? What kind of progress has been made in implementing the strategy?
There are a number of innovations happen on 3 dimensions. One is the collaborative innovation. So the number of industry and government organizations working together to solve this problem. So that's one of the biggest strengths of this UTM project and research activity. Second is that because of the so much interest in this activity, we had to kind of get support from our legal folks and others who are working with us on agreements, and we were able to come up with agreements, the templates for agreements that went faster in terms of relationships with industry and government. So that was the second piece. And the third particular piece that we are able to do is we dissect this big problem of safely enabling multiple beyond visual line of sight operations using risk-based approach. So we categorize the whole UTM research, body of research, in 4 technical capability levels. The first one was just focus on figuring out the roles, responsibilities, overall architecture, what information gets exchanged among operators, between FAA systems and the operators and the users of the airspace, what data they need like weather and 3D maps and such. So that was the initial step, which is the defining the architecture and the exchanges among operators. Roles, responsibilities was the second one. As I mentioned, there is a role for Federal Aviation Administration or any air navigation service supplier. Second role is the unmanned aircraft system support services. So these services could be flight planning, tracking, communications, and such. Third is the operator themselves. So we define these roles, which are unique in this architecture and this operating paradigm. Third, we did basically the data exchange protocol. So in the first capability level, technical capability level, we define these services, we define the protocols, we tested them electronically. So there is no voice communication. It all happens through data exchanges. Second technical capability level, which increases the risk. So first capability level was sort of very remote areas over water and such within visual line of sight. Second one goes to beyond visual line of sight, which we tested last year. We defined the requirements as to how do we make sure that you can safely operate vehicles beyond visual line of sight, particularly multiple vehicles. So when you plan your schedule, when you plan your area of operation, you can actually exchange that with other operators who are in the vicinity, so everybody stays away from each other. Part of the beyond visual line of sight is that you are where you said you are going to be. So making sure that you track the vehicles and locate them and stay within the bounds that you said you are going to be. So that capability then we built in the UTM system prototype. The third technical capability level that goes into another level of complexity is that having multiple vehicles do vehicle-to-vehicle coordination. So you have scheduled plans and you are staying away from each other, so that's strategic deconfliction. And then what happens if you get too close to each other, then you have vehicle-to-vehicle coordination when they are in flight and stay away from each other. You also want to make sure that the vehicles have awareness, or the vehicle operators, the drone operators have awareness of other manned aircraft in the airspace so they can stay away from each other. So third capability level focuses on heterogeneous operations and coordination inside the airspace among operators. And then the fourth capability level focuses, which is the highest complexity level, focuses on urban airspace and the contingencies involved in the urban airspace. Urban airspace could have lots of constraints, buildings, cranes, structures, as well as manned aviation nearby, near airports and such. So we want to not only go beyond visual line of sight, we want to have heterogeneous vehicles, but we also want to try this in the urban airspace. And what's interesting about all this is if we are successful and we demonstrate that all the capability levels and the requirements can be accomplished, then it sets a nice stage for next urban air mobility type of operators, which is the electric vertical takeoff and landing passenger carrying aircraft that would go in and out of urban airspace. To summarize, we have basically 4 technical capability levels. First one we demonstrated 3 years ago. We tested the data exchanges and interoperability. Second one, we tested the beyond visual line of sight and identified requirements to operate multiple vehicles beyond visual line of sight. The third technical capability level looks at heterogeneous operations beyond visual line of sight. And the fourth technical capability level adds to the third capability level and operates in the urban airspace.
And the first 2 have been successfully completed. Is that correct?
That's correct. The first 2 have been completed. The second one was completed last year. We are now testing the third capability level. The testing will go on between March and May of this year.
Have there been any notable surprises or things that came out of the first 2 capabilities that weren't expected but were helpful in moving the project forward nonetheless?
Absolutely. There were some interesting observations in the first 2 and interesting data we found. For example, if you are operating in airspace that is at a higher altitude, so take example of Reno State Airport, which was about 5,060 or 5,090 feet. And when you're operating there, the air is already thin. When you have strong winds and you have hot air because the temperature is high, 94 degrees, 100 degrees, then you can see that the battery or the energy has to be consumed more because you're basically fighting against headwind, you're fighting against the thin air, and battery life goes down significantly because you're consuming extra energy. So that was one interesting observation. Second interesting observation was, even though we say that the manned aircraft need to stay away from it, there are times when we see no radio, no beacon kind of vehicles, aircraft, general aviation could occur in that airspace. So fortunately, we had ground-based sense and avoid detection radars, and they fed information into UTM. UTM immediately basically said, hey, there are vehicles, aircraft that in the sky that we need to then take action. So we had all the drones land immediately. So that was the second interesting observation. Third one was basically had to do with altitude. So some folks were using different altitude referencing schemes. So some of them using above ground level from the ground control station, some of them using above ground control level where they were operating at that point, some of them using mean sea level. So we had to standardize these things so that there will be compatibility of that. Fourth observation was, in some cases there was updraft, which is the wind going up, and that made the aircraft go up and bounced around quite a bit. In some cases, the ones with the fixed wing with low wing loading, means lighter wing loading, jumped up a couple of 100 feet. So that gives you an impression as to how close you can let them operate with each other based on the performance characteristics of the vehicle.
In order to implement this program, what capabilities needed to be developed that didn't exist when the UTM was being formulated?
So when we started the UTM, first of all, that's the concept of cooperative traffic management with participatory nature, with intent sharing and everything digital didn't exist. So we had to develop this concept. Then we built the data exchange protocols and application protocol interfaces. And we are also building sense and avoid technologies. A number of companies are also building that. So we're collaborating to see how the sense and avoid capabilities will work. These drones are smaller in size, weight, and power, so their ability to carry bigger sensor packs is limited. So we had to make sure that we are able to carry also sense and avoid technology. So we are working on that, or vehicle-to-vehicle communication for detect and avoid. So that didn't exist, particularly catered to the small vehicles, and we are working on that as well. So what didn't exist is the scheduling capability, the standardized data exchange protocols, sense and avoid, and communication in some cases where you need to kind of set the requirement if you want to track your vehicles. Some cases your cell phone or towers didn't exist, so then you need to figure out how else I can track them. So there may be GPS availability, there may not be GPS availability. Then so you set some requirements on how you want to track them for operators. The tracking is essential for operators because they want to make sure that they can assure that they are where they said they're going to be.
I'm curious how the partnership structure works. I see various initiatives around the country. For example, the UTM corridor in New York and the work at the various FAA test sites. Is NASA leading these efforts, or are partners or regions allowed to bring an idea to NASA for consideration?
Yeah, the latter, basically, in a nutshell. But the idea is to have number of testing places. Each testing place has its unique characteristics. That's why FAA has 6 test sites. We are working through all 6 FAA test sites. The New York example that you articulated has UTM corridor that they're building outfitted with sensors. Other test sites are doing similar things. And we also rolled out between FAA and NASA something called UPP, which is the UTM pilot project. So it's an acronym inside acronym. And in that UPP, we will be rolling out what we have studied in TCL 1, 2, and 3 now, and operationalize some of these capabilities to understand how these operations could occur in a sustained manner.
What can we expect to see for the rest of the year?
So this year, FY 2018, which ends in September, we will be focused on technical capability level TCL 3, where the vehicle-to-vehicle communications as well as vehicle into the UTM communications will take place for detect and avoid, as well as the scheduling and planning pieces that we already have in the UTM. That will be the emphasis of this year, and next year will be focused on the urban airspace.
How well funded is the initiative right now? Is it totally funded by the government, or is it in partnership with industry and other players?
So that's a great question. So the NASA's research and the test and the software development and the prototype of UTM that we will hand it over to FAA for further testing and operationalization is something that's funded through NASA. When we do the flight test and such, the industry funds their own participation. If they're building a vehicle capability or some U.S. support services, they fund that and they participate on their own funds. And we are really fortunate to have such cost-shared opportunities and collaboration. This is really, as I was mentioning before, this is really a great example of government, industry, academia, and FAA test site tight partnership, and it's cost-sharing between partners.
What do commercial operators need to know about the UTM at this point in time?
That's a great question. I think the UTM does 2 things for operators. One is it opens up market for U.S. service suppliers. So you can be a supplier of these services for planning and scheduling, tracking vehicles and communications and such. So that's one market that opens up. And second is by being part of the UTM collaboration, being part of the flight test, you are able to demonstrate the capabilities you have, show that you can interoperate with other vehicles and other operators in the sky, and overall ability to set requirements on what requirements should be finalized so that we can all operate in a safe manner simultaneously beyond visual line of sight.
Is there a connection between the drone integration program that was announced in the fall and the UTM initiative?
There is a connection with UTM. Clearly, if you read the IPP's requirements, there are a couple of places you will see references for UTM. It says IPP will test UTM technologies, and it also calls out collaboration with NASA where the data could be shared with FAA and NASA from IPP so that we can solidify the requirements for UTM.
Is there anything that we missed that we should talk about?
I think you have covered everything in this. UTM has been a good example where there's a lot of interest domestically as well as outside. Japan is following this model. They call it JUTM, Japan UTM. Korea is following the model, KUTM, they call it. New Zealand, Europe is following the model. They're calling it U-Space. Number of other countries are following the model. International Civil Aviation Organization is very interested in making sure that the UTM construct is harmonized so that operators can take advantage regardless of which country they operate.
When will we see the implementation of the UTM?
The interesting part of UTM is the relationship between FAA and NASA is so strong that we are not waiting, and FAA is not waiting to complete entire UTM and deploy things all at once. But as and when things get mature, solidified, they take it on and transfer it. To give an example, the data exchanges, the roles responsibility model, the USS and the US operator and flight information management system, or the FAPs that we built, and we collaborated with FAA. FAA already implemented that roles responsibilities as well as some of the data exchanges that were applicable into the low altitude authorization and notification capability, or LANs. Then through the UTM pilot project, they will be operationalizing, at least on initial trial basis, some of the capabilities and the requirements that we have identified in technical capability level 1 and 2. And as and when we identify these capabilities and requirements, we feed into the FAA colleagues through something called research transition team, and as appropriate, they take it and figure out whether to use it for operationalization or their prototype or rulemaking kind of decisions. So it's not all or nothing. It sort of goes in a gradual, incremental scale.
So essentially, we'll see things rolled out as they are finalized.
That's right, yeah.
And my last question, PK, what would you like people to know about NASA's commitment and their role in developing the UTM system?
The first day in NASA is aeronautics, and one of the parts of aeronautics is the air traffic management related research and development, and NASA has been doing that for the last 25 some years. UTM was one more item that we are very passionate about from NASA, and we are really happy to collaborate tightly with FAA and industry, and it's a really good example of how government contributes to overall benefit of the public and the industry and overall safety of the airspace operations.
That's it for episode 151 of the Drone Radio Show. I hope you enjoyed hearing from Parimal Kopardekar of NASA's Ames Research Center and learning about the Unmanned Traffic Management System. I want to thank PK for taking the time to speak with me. If you want to learn more about the UTM or want to connect with PK, check out the webpage at utm.arc.nasa.gov. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1 per month, you can help defray the costs of production. To donate, go to patreon.com/Drone Radio Show. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.